All right, this problem reads, if the side of a square is x plus 1, then the diagonal of the square is one of these four expressions. All right, so basically what we have to do is take the given information that each side of the square is x plus 1 and use it to determine what the length of this square's diagonal is. Now, we should notice that we're dealing with a right triangle. Therefore, we are going to use the Pythagorean Theorem, which is a squared plus b squared equals c squared. So basically, squaring each one of these two legs and adding them together should be equal to one of these four choices to the second power. So let's plug x plus 1 into a and b. So we have x plus 1 squared plus x plus 1 squared is equal to c squared. All right, to square this binomial, I'm going to make a 2 by 2 table to help me along here. So on the top, we're going to write x plus 1 times x plus 1. This will keep me organized. Now, I'm going to take x times x, which is x to the second power, and 1 times x, which is just 1x. And here we have to multiply x by 1, which is, of course, just x. And 1 times 1 is 1. Now, out of these four terms, only these two terms are like terms, so we can only combine those two. So we came up with x to the second power plus 2x plus 1. Now, because b is the same value as a, we just have to write this same expression one more time. So we have x squared plus 2x plus 1, and we have to add those together, and that is equal to c squared. All right, so now we have to combine like terms. We have two terms that are x to the second power, so we can say that is 2x to the second power. We have a 2x and a 2x, which all together is 4x. And we have 1 plus 1, which is equal to 2. So we write plus 2, and that is equal to c to the second power. All right, now what we're going to do is square each one of these choices until we get something that is equivalent to this expression right here. All right, so let's take x to the second power plus 1 and multiply that by itself, x to the second power plus 1. And in this box here, we get a product of x to the fourth power. Remember, when multiplying bases that are the same, we take the exponents and we add them together. 1 times x to the second power is x to the second power. Here, same thing, we have x to the second power times 1, which is x to the second power. And here we have the product of 1 and 1, which is 1. Now, we should notice right off the bat that this is not going to be equal to this expression. If we were to add all of these terms together, we would get x to the fourth plus 2x to the second power plus 1. Notice we do not have any x to the fourth power terms in this expression, so we know that we can eliminate choice A. All right, let's go ahead and square 2x plus 2 and see if we get an equivalent expression. All right, so here we have 2x times 2x, which is 4x to the second power. Here we have to double 2x, which is 4x. Same thing here, we're going to double 2x, which is 4x. And here we get 2 and 2, or 2 times 2, which is 4. And that would give us an expression of 4x to the second power plus 4x and 4x. Those are like terms, so we can combine those. That would be 8x plus 4. And as we can see, this is not equivalent to that expression, so we can eliminate choice B. All right, let's take x times the square root of 2 plus the square root of 2 and multiply that by itself. X times the square root of 2 plus the square root of 2. Now, one thing we should remember is when you are squaring something that is under the radical, all you have to do is write what is underneath the radical one time. That is going to be your answer. For example, let's say you had the square root of 9 times the square root of 9. We should understand that the answer is just going to be 9. Because if we took the square root of 9, that would be 3 times 3, which would be equal to 9. So we can just take what number is being squared under the radical and write it one time. So the square root of 2 times the square root of 2 is just 2, and then x times x is x to the second power. All right, once again, we have the square root of 2 times the square root of 2, which is just 2, and we only have one x here, so we only have to write that one time. And we're going to get the same thing here in this box, 2 times x, because we have the square root of 2 times the square root of 2, which is just 2, times that single x we have. And of course, the square root of 2 times itself is going to be just 2. All right, let us go ahead and combine like terms. We have 2x to the second power plus 2x and 2x, which is 4x, plus 2. All right, as you can see, this expression is equivalent to this expression. Therefore, choice C represents the length of this square's diagonal.